Okay, today we're going to be talking about evaluating functions. Remember, evaluate is just a synonym for the word solve. Okay? A function is like a machine that uses a rule to create outputs when inputs are entered. Well, what do you already know about outputs and inputs? Correct. Which one's which? Inputs are x values, which is domain. Outputs are y values, which is range. And that's what the first statement says. In the ordered pair x, comma y, x is the input and y is the output. Okay, it's called the input because you're going to input it into the equation, and what it produces, the answer it produces, is called the output. The domain is the set of inputs, and the range is the set of outputs. Okay, and that's nothing new. You learned all that yesterday. For questions 1 and 2, we're going to use the set of ordered pairs shown below to answer these two questions. Find the output associated with an input of 2. Okay, because we know an output is a y value associated with an input, which is an x value of 2. Well, that would be this ordered pair, 2, 4, so the answer is 4. Okay, let me say that again in case I confused anybody. It says find the output, which is the y value associated with the x value of 2. Well, the only ordered pair up there that has an x value of 2 is this one, and its output is 4. In question 2, it says find the input, so this time we're finding the x value associated with the output of 2. Which ordered pair is that? 8, 2. So that answer would be 8. Okay, to read the notation f parenthesis x parenthesis, you're going to say f of x. Okay, that's how you say that, f of x. The notation f of x can be used interchangeably with y on the left side of the equation. So we're used to seeing like y equals over and over with equations. Today, since we're starting function notation, they're going to put things like f of x equals, or k of x equals, or g of x equals. And the reason they do that is so you can see what's being input into the equation. And that'll make more sense when we start doing them. Okay, so in this function, doesn't that look just like y equals mx plus b? They're just choosing to use f of x instead of y, because they can be used interchangeably. What is the input in this equation? The x, that's where you would input a number, correct? And what is the output? Okay, but instead of y, they've chosen to use f of x. The function k of x equals -4 is called a constant function. Now, the reason it's a constant function is because it will always be -4. Okay, there's no variable over there with that -4 that can change it. There's nowhere to plug in anything, correct? So it will always remain -4, and that's called constant because it stays the same. Okay, now let's actually try some problems. Let's go to page 26. All right, number 3, evaluate t of 9 if t of x equals the square root of x minus 2x. It's not hard, I promise. This is very easy. See how it says evaluate t of 9? Well, isn't 9 just sitting in the place of x? So that means 9 is our input. 9 is our x value. So we take this function and we rewrite it, but instead of the x's, we're told to input a 9 in their place. Now just type that in the calculator and you'll know what t of 9 equals. Okay, what did you get when you input 9 into this function? And that, oops, wait. And that is correct, negative 15. Okay, now, the reason they write it like this instead of y equals negative 15, they write it like this with t of 9. That way they know that the reason you got negative 15 is because your input was a 9. Okay, 9 is your input, negative 15 is your output. Now let's try number 4. What is the input for number 4 going to be? Negative 1. So inside these absolute value bars, you're replacing the x with a negative 1. Then you're going to subtract 4 from it. And then on the outside, you're going to add 8. Well, what does negative 1 minus 4 become inside those absolute value bars? Negative 5. What do absolute value bars do to a number? Change it to positive. So won't this just end up 5 plus 8? So 13. When the input is negative 1, the output is 13. Now, most of you are fine with just doing the absolute value thing by yourself without a calculator, but I would like to show you how to do absolute value in the calculator in case you ever want to. The first thing you press is the math button over here under alpha. After pressing it, you'll go right 1 to the NUM for number, and then see the very first option, ABS, that's for absolute value. So you can either hit 1 or, since you're already on top of it, hit enter and see how it gave you absolute value bars. Then you can type in whatever you want, and in our case it was negative 1 minus 4, and then on the outside plus 8, and we got the same thing, 13. Okay, so all you do is hit math, go over to num, and then there it is, the first option will give you absolute value bars. Alpha y equals n over d. You're welcome. Okay, now let's try number 5. Evaluate g of 5 if g of x equals x minus 4 over x plus 3. So this time they're asking us to input what number into the function? 5. So if you replace this x with a 5 and this x with a 5, what does the numerator become? What does the denominator become? 8. And so when your input is 5, your output is 1/8. Because you can't simplify 1/8. They won't reduce. It won't become a whole number, so that's your answer. Yes, come over here. Before we start working on the graph ones, let's practice what we've learned so far. Go to page 27. And I want you to work set 1 and set 2. Set 2 goes over to this page, or to this side a little. Okay, set 1 is 4 problems. Set 2 is 4 problems. I'll give you just a few minutes to try those before we move on. 1 through 4 are simple. In the set of ordered pairs, what output, so what y value is associated with an input of 3? 6. Okay, this is an input of 3, so the output associated with it is 6. Number 2, in this set of ordered pairs, what output is associated with an input of negative 1? 3. Okay, it would have been this ordered pair. Number 3, in this set of ordered pairs, what input is associated with an output of 6? Right, this time they asked it the opposite way. They wanted to know what x value is associated with a y value of 6. Well, here's your y value of 6, and it's associated with 3. Number 4, in this set of ordered pairs, what input is associated with an output of 0? Negative 4, it would have been this one. Any questions about how to do those? Okay, set 2. Evaluate g of negative 1. So we're trying to figure out what g of negative 1 equals if g of x equals the square root of x plus 10 minus 3x. So all you're going to do is input negative 1 into the function. So it'll become the square root of negative 1 plus 10 minus 3 times negative 1. And what did y'all get? I got 6. Because look, Leah, negative 1 plus 9, negative 1 plus 10 becomes a 9. The square root of 9 is 3. Negative 3 times negative 1 is a positive 3, and then added together is 6. Or you could just type it straight in. All right, number 2. Number 2. This time they want you to evaluate r of 4. When you plugged in 4 for both z's and you squared it and you multiplied by 2 and all that, what did you get? 9. Look, 4 squared is 16. 2 times 4 is 8. And then 16 minus 8 is 8. 8 plus 1 is 9. Shh, guys, we got to keep moving on. Evaluate g of 3 if g of x equals negative 15. Right, this is a constant function. There's no x over here to plug the 3 into, so the answer remains negative 15. It's a constant function. Okay, and then evaluate h of negative 5 if h of x is 3 over x minus 1. Right, because when you first did it, it would have been 3 over negative 6, right? Because negative 5 minus 1 is negative 6. And then once you simplify that, it's negative 1/2. Okay, now let's go back to page 26 and learn how to do the graph ones. Okay, use the graph of g of x to find g of 0, g of 2, and then we're not doing g of negative 4. I changed it up down there to something different. Well, I changed right here. Okay, you got to pay attention because while this is easy, it can be very confusing if you're not focused. Okay, look, g of x, okay, look, g of x. So if I now have g of 0, 0 is sitting in the place of what? X. So if I go to the x-axis, which is the horizontal axis, and I go to 0, what point on this graph has an x value of 0? Isn't it this one? What is that point's y value? 4. So g of 0 equals 4. You're looking for the point on the graph that has an x value of 0, which is this one, and then you give the y value. So the next one, we're looking for the point with the x value of 2. Well, this is 2, so the point with an x value right there would be this one way up here. And what is its y value? 6. Okay, what's different about the third one? Right, they didn't give us the x this time, they gave us the y. So you need to go down the y-axis to negative 2. Isn't this point over here the one that has a y value of negative 2? What is its x value? Negative 6. Look, this point right here has a y value of negative 2 and an x value of negative 6. Okay, now let's go over to the right-hand column. Use the graph of h of x to find h of 1 and then write its equation. Okay, h of 1 means that 1 is replacing the x. So if I go on the x-axis, write 1, how do I get to the line? Up 3. So h of 1 equals 3. Now, when we write the equation of a line, we're used to writing it in the form y equals mx plus b. But they're no longer calling the y-axis y. They're calling it of h of x. So you're just going to replace the y with h of x. And then after that, you'll do everything else the same way you always have. We need an m and we need a b. How do we find either one? No. Okay, it is plus 1 because isn't b your y-intercept? And doesn't this line intercept the y-axis at 1? How do you now find the m? What is m? Slope. And what's another way we call slope? So won't we just rise 2, run 1? So 2 over 1, or you could just put 2 if you wanted. Okay, now turn to page 27. There's nothing there. Okay, number 27, go over to set 3, number 1. It's 2 over 1 because you had to go up 2, right 1 to get from the y-intercept to the next point on the line. Okay, set 3. Use the graph of g of x to answer the questions below. g of negative 1. Okay, negative 1 is our what value? X. So if we go to negative 1 on the x-axis, to get to this graph of a parabola, don't you just go right here? And then that pretty much y equals 1? So g of negative 1 equals 1. So in this problem, they didn't give us the x value, they gave us the y value. So on the y-axis, we go up 3 units. To get to that parabola, what do you need to do? Right 2 or left 2. There's 2 places to have a y value of 3. So it could be either, or actually it's both. 2 and negative 2 would equal 3. Both of those values are x values that have a y value of 3. Yeah, I mean, it would be like multiple choice, and it would say 2 and negative 2. Okay, now go to the next page. Use the graph of h of x to find h of negative 4. Okay, what would h of negative 4 equal? Right. If you go to negative 4 on the x-axis, there's a point right there at negative 4, and its y value is 0. And then h of what equals 5? 2. This point right here would have a y value of 5, and its x value is 2. Okay, then use the graph of f of x to find f of 1, then write the equation of the line. So f of 1 equals, and then f of x equals. What is f of 1? 3, because if you go right 1 on the x-axis, to get to the line, you have to go up 3. And then now we need the line in the form mx plus b. Well, what's the b? 1, 2, 3, 4, 5, 6 is your y-intercept. And then how do you find your m? Okay. Well, look, here's our first point, our y-intercept. To get to this point, down 1, 2, 3 over 1. So negative 3 over 1. So yeah, I don't know what point. You're right, because yours would reduce to negative 3 over 1. Okay. Yeah, that's fine. Okay, this is your homework. Yes. Page 29 and 30. Okay, but you're not doing it all. You're going to do 1 through 8, which are those very easy ones that take 2 seconds to do each problem. And then you're going to do 17 through 26, which is the graph ones. The reason I'm assigning this homework is so Monday we can do a game.